This piece of equipment is called a Wright's Respirometer. It is used for measuring volume. As flow of gas goes through this device, it spins the dials on the front and the volume is measured. It's important to note when using the Wright's Respirometer that gas will only be measured with this device when it is flowing through this device in the direction of the arrow on the screen. There's a number 1 that you can't see at the bottom of this screen, and the arrow then flows to the number 2. That's the direction the gas has to flow in order to be measured. I've attached a mouthpiece to this Wright's Respirometer and put an arrow to show how the exhale volume will be measured by this device. If you would like to measure inhaled volume rather than exhaled volume, simply switch the mouthpiece to where the number 2 was on one of the previous pictures in this movie. You'll see here only the inspired volume will be measured through this device. In order to do this, you need to use different connectors. These are 2 common types of connectors that are used in respiratory therapy: 15mm connectors and 22mm connectors. You'll see here I had to add a 22mm connector between the mouthpiece and the Wright's Respirometer in order to connect the mouthpiece. In this one, when I was measuring inhaled volume, I did not need any additional connectors at all. The mouthpiece fit directly onto the Wright's Respirometer. The Wright's Respirometer has a reset button on one side of the device. Press this button just before you'd like to start your measurements. On the other side of the device is an on-off switch. Always leave it in the on position. Otherwise, if you try and push gas flow through it and it is in the off position, it will damage the device. All right, let's look at some measurements with the Wright's Respirometer. In order to read this device, you have to look at the skinny black hand first and then the thicker red and black hand second. So the skinny black hand is pointing at the 4th dashed line over, so that's 4 liters. And then the red and black hand, thicker one, is pointing at the 0.4 liters. So this is 4.4 liters. If you measured this in 1 minute, that would be the minute volume, 4.4 liters. If you measured this in 30 seconds or half of a minute, you would get double this volume if you measured over 1 minute, so it would be 8.8. So you always have to be aware of not just how much volume you measured, but how long it took you to measure that volume. Well, let's look at the small skinny hand first. It is pointing at the 9th dash, or probably just before the 9th dash, so I would call that 8. And then I'm looking at the red and black hand, and it is above the 0.65 mark, so I would call that 0.66. So based on the hands on a clock, that's kind of similarly how it operates. I would call this 8.66 liters. All right, so let's say you wanted to figure out what the average volume per breath was. And this was our minute volume we had measured, 8.66. In order to figure out the average volume per breath, you need to divide this volume by the number of breaths in a minute. So let's say it was 8.66 liters and you took 10 breaths in a minute. 8.66 liters divided by 10 breaths is equal to 0.866 liters per breath, or 866 milliliters per breath. That would be your average tidal volume. So let's say that we had this same minute volume, 8.66 liters, but you took 20 breaths in a minute to achieve that 8.66 liters of minute volume. So in order to figure out the average volume per breath, or the average tidal volume, you need to divide the 8.66 liters by the respiratory rate of 20, and you would come up with 0.433 liters per breath. Well, that's the same as 433 milliliters per breath. So you had the same minute volume, but it took you more breaths, 20 instead of 10, in order to achieve the minute volume because each breath was smaller. So it's important to note not only how much volume you measured and not only how long it took you to measure the volume, but how many breaths it took to achieve that volume.